Guys, I kind of can't believe what I'm seeing right now. So on the bench, I have a pair of Taramps HD10K. These are literally identical HD10Ks. And I was looking at this one. I've repaired both of these. Both of these are absolutely fully functional, exactly as out of the factory. I have spent tons of time rebuilding these exactly perfectly. And I was just getting ready to sell this bottom one here. I just thought, you know what, just give it a test on the bench, make sure everything's all right, run it for a half hour, you know, just to double check. It's been sitting for a couple of months, so I just wanted to double check it was all good still. I didn't have any of my PC or my music or anything on, and usually I usually have a bit of background noise in the workshop. And when I hit the remote for this bottom amp, I heard a kind of tick sound, like a click sound. And these amps don't have relays. There's no mechanical parts in these. There's nothing that should be making like a tick sound, okay? Now, if you have electronics that don't have mechanical parts and you hear a sort of tick sound, that usually is a big spike of current being dumped to ground somewhere, okay? I'm used to hearing this sound when MOSFETs fail but don't explode, or notably in SG3525 powered amplifiers that use that chip for the power supply oscillation. When you first apply the remote to those amplifiers, you get a little bit of a spike sent to the power supply MOSFET gates, and it causes a bit of a current spike for like a tiny split second. Those FETs are usually pretty rugged, so it doesn't cause any long-lasting damage. However, I noticed it on this Taramps amplifier here, and I was like, what's going on? Why is it doing that? So then I decided to hook up to the scope and probe the power supply MOSFET gate while I apply the remote. And what I found was this. So this only occurs after the amplifier has been powered up fully, like operational, fully running, powered off, and then powered back on again. It doesn't seem to happen from a standing cold power on after it's been left for half an hour or so. It's only after it's been powered up after already being powered on, like, you know, recently. When you apply the remote, the MCU sends this absolutely gigantic spike of voltage down the gate path to all power supply MOSFETs simultaneously. So that turns on the A and the B side of MOSFETs at the same time, meaning that they just see a short circuit to ground. And if you've obviously got high current 12 volt supply hooked up, like a lithium battery bank or something like that, then these MOSFETs are going to try and dump as much of that current to ground as possible for the duration of this pulse. Now, the MOSFETs that I fitted to this amplifier here, this bottom one, are very highly rated in terms of their current rating and their, their wattage rating. So these are really good FETs. However, because they have an extremely low RDS on value, they are more fragile to short circuit environments, because a short circuit environment through these FETs, due to it have a lower RDS, will actually allow more current to spike through the FET than a higher RDS FET. Which is what I've used in this one. Slightly higher RDS, slightly lower RDS, just what I had on hand at the time. Both are absolutely within spec for normal operation up to rated power and beyond of these amplifiers. However, when you've got a short circuit environment here where you've got a spike and it's just dumping current to ground through the MOSFETs, these ones, which are technically higher current with a lower RDS, these ones actually fail. They short. Even on my 40 amp bench power supply, because you've got energy stored in these capacitors here, there's a lot of potential current that can immediately be shorted through the FET. So even on my bench here, these MOSFETs down here failed after about the third or fourth attempt of me trying to figure out what was going on with this spike on the gate. So I hooked up a 47 ohm resistor in series with the power terminal just to kind of mitigate current, but you know, I can't really get around there being caps right next to the FETs. Can't really get around that. So they're still failing every now and then as I've been trying to diagnose this. So I thought, well, there must be something wrong with this amp. Maybe there's a problem with the MCU or the voltage which is supplied to the MCU or the remote turn on circuit. So I grabbed up my other Taramps HD10K. This amp has been running for 3 years in my demo van at 0.5 in its exact form. I haven't repaired it for 3 years, and it's been running beautifully for a long time now, you know, being powered on, being powered off at multiple times, etc. So because the MOSFETs in this are higher RDS, this still spikes. This one has the spike as well, and that's what I wanted to check. I was like, is this a problem with this amp, or is this something that all HD10Ks do? And turns out it's something that all HD10Ks do. I don't know about the 15Ks or any of the 8Ks or anything, but both of these amplifiers have original MCUs. both are, you know, repaired to factory standard, and they both do this exact same behavior. So this is a design flaw with the MCU or the supply voltage generation to some of the circuit. I'm gonna have to try and figure out now. Very frustrating and kind of crazy. I have known for a long time that the power supply sections in these amps have not been most reliable. Like usually when the HD amplifiers fail, it's the power supply that fails, which is why these get a bad reputation for catching fire, because when the power supply section fails, you get all the smoke and stuff because it's just cooking on the 12 volts. So I think this might be why. If this is spiking the MOSFET every single time you turn it on, or after it's been powered up recently and you turn it on again, that's going to just gradually be degrading these MOSFETs over time. And then eventually they're going to fail. The output sections in these are super reliable. You rarely ever have to repair the output sections. It's always a power supply. And I think this is why. So I just wanted to make this video for documentation of that. And for your interest, I guess, I'm going to have to try and now come up with a solution to correct the design flaw which causes this. Lovely.